Good evening, everyone. So, welcome to the fifth tutorial of this course. In this tutorial, I'll be solving assignment 5 from last year's course. So, if you have any confusions regarding the lectures, you can unmute and ask, or you can write in the comment section. So, let me share the screen. So, as I am solving the problems, I will request you to solve it parallelly. It will be a good exercise for you. So almost all problems of this tutorial will be on double integral. First one is we are asked to calculate e to the power 2x plus y dy dx, and y is going from, so this is the y limit, y is going from 1 to ln 5, and x is going from 0 to ln 2. So if I draw the region, so it will be, so x is going from ln 2 0 to ln 2. So this is ln 2, and this is ln 2, and this is ln 5. So then we are asked to integrate this quantity e to the power 2x plus y in this region. So as this boundary, so x limit doesn't depend on y, or y limit doesn't depend on x, so we can integrate either x limit or y limit first, so it doesn't matter what we integrate first. So y is going from 1 to, sorry, y is going from 1 to ln 5. This is the region we are asked to integrate, 1 to ln 5, and x is going from 0 to ln 2. So I'll integrate the y first. So I can put it to the power 2x outside the integral. So it will be to the power y dy, where y is going from 1 to ln 5 times dx. So now this integral to the power y dy, it will be to the power y, and y limit will be going from 1 to ln 5 dx. So it is a constant. I can find its value here also. So it will be e to the power ln 5 minus 1 upper limit minus lower limit, sorry, minus e to the power minus e to the power 1 is e, which will be 5 minus e. So I can put this outside, 5 minus e, and then to the x integral, x equals to 0 to ln 2 to the power 2x dx. and if I do this integral, it will be, so 5 minus e is there, so it will be to the power 2x by 2, and lower limit is 0, upper limit is 2. 5 minus e is 2, and so it will be e to the power 2 times ln 2, which means 2 times ln 2 means ln 2 square minus e to the power 0. So ln 2 square means 4, ln 4, it is 5 minus e, and ln 4, e to the power ln 4 means 4 minus 1 by 2, so which is 3 by 2 times 5 minus e. So the correct option is the second one, 3 by 2 times 5 minus e. So in the next problem, we are again asked to integrate dx dy cos y. This is the term we have to integrate, and the region is given as, so x is going from minus 1 to 1 and y is going from 0 to pi. So x is going from minus 1 to 1 and y is going from 0 to pi. So in this region, we are asked to integrate this quantity xy cos y. So similarly as before, we can see that the region boundaries, it doesn't, so x limit doesn't depend on y, or either y limit doesn't depend on x, so we can integrate either either x first or y first. So xy cos y, I can write dA as, dA basically a small area element, like this, so it is dx times dy. So dx times dy, and x will be going from minus 1 to 1, y will be going from 0 to pi. So if I do the x integration first, keep y equals to 0 to pi, and then if I do the x integration first, you can see it is only x dx, and x is an odd function, so the integration will be 0. So if I do the integration, it will be x square by 2 from minus 1 to 1, and this cos y cos y dy remains, and this term, if you put the limit, it will be half minus half, so it is 0. 0 times the entire thing, that will be also 0. So the value of this integral is 0. First option. Okay. In the next problem, we are asked to find out the volume of the region bounded above by the plane z equals to 2 minus x minus y, and below the square region, so where x going from 0 to 1 and y also going from 0 to 1. So let me draw the region first. So when xy equals to 0, so it will cut the z-axis at 2, it will cut the x-axis at 2, it will cut the y-axis at point 2. So this lengths, so these points are 0, 2, 0, this point is 0, 0, 2, this point is 2, 0, 0. Then the plane will, so this will be the plane, this will be the plane z equals to 2 minus x minus y. Right, so then we are asked to integrate below this plane and inside the square region. So the square region is, so you can see this point, so if when x is 1, this is the region we are asked to integrate. So x will be going from 0 to 1 and y will be going from 0 to 1, and this point will be 1, 1, 0. Okay, this point lies on this plane. So the so the region we have to integrate is basically this is the plane. Okay, so we need to find this volume. So this is, so this part, this blue part is from the plane part, and this other part, these are from this because of this region we have the square parts. So you have to find the area inside this volume. I think the drawing is clear. If not, then please ask. Okay, so how to get that volume? So at any point xy, we will consider a small area element, which will be dx dy basically. This length will be dy, this will be dx. So this small area element will be dA, which equals to dx dy. And and if I take the volume above this area element, which belongs to this, which is inside this uh, this this plane, inside this blue plane, and this base square, so this pink square, so it will be it will look like this. Okay, this is an infinitesimal volume, so if I call it dV, this volume, so it will be given by this area dA times the height corresponding to the at this point, so that will be z. And now if you want to find out the entire volume, so we need to integrate, so we need to sum this all dV's, so to integrate them, so the total volume will be integration of dV, which is integration of z dA, and that will be, so dA, for dA there will be double integral, z dx dy, and as we are in the square region, so the boundaries are square boundaries, so we can integrate either x first or y first. So let me first integrate x first. So x is going from 0 to 1, and y will also be going from 0 to 1. And this z is 2 minus x minus y dx dy. Now if I do this to v y equals to 0 to 1, if I do the x integration, so for the first term it will be 2x, for the second term it will be minus x square by 2, and for the third term it will be xy. Here we put the limits, so x equals to 0 to 1 dy equals to 0 to 1. If I put the upper limit, it will be 2 minus half minus y. So I'm putting x equals to 1, and if I put the lower limit, the all term will be 0. Because if you put x equals to 0, everything will be 0. So times dy. Now this term, this two term will be 3 by 2. So y equals to 0 to 1, 3 by 2 minus y dy. And now if I do the y integration, it will be 3 by 2y minus y square by 2, and integration limit is from 0 to 1. So the upper limit, it will be 3 by 2 minus half, and if I put the lower limit, it will be 0. So then if I do the subtraction, it will be 2 by 2, that is 1. So the volume covered by this region, it will be 1. So if how I drew the volume is not clear, or how I do this integration, so how I'm putting the limits, then please unmute and ask, or write in the comment section. Okay, so again we are asked to integrate this quantity f of xy inside this region. So now we have a region where x is going from 1 to 2, and y, so y will be going from, so y equals to x, y equals to x, so this is a y equals to x line, y equals to x, and y equals to 2x, so y equals to 2x. Third question answer option B. Yeah, yes. Sorry, it is 1. Yeah, the volume is 1. Thanks. So the area inside which we have to integrate, that will be from this y axis, and this line is y equals to 2x. So we have to be inside this area. Okay, so the y limit will depend on x. So in that case, we will integrate y first, and then we will integrate x. Okay, so how we are doing it? So let me draw small. So if we are integrating along y first, so it will be like f of xy dy. Y is going from x to 2x. So at any point x, this will give this line. This is the dy. So at any point x, so this quantity will give me the integration along this line. And now if I multiply with dx, so what it will give me an integration along this small area patch. And now if I run through, so if I integrate, now if I integrate through x from 1 to 2, so it will cover the entire, it will basically cover the entire area. This will cover the entire area. That's what I am going to do. So first I will integrate along y, and then I will integrate along x. So x equals to 1 to 2. And f of xy is x by y, is equals to 1 to 2, y equals to x to 2x, and f of x is x by y dy dx. So now while I'm integrating with respect to y, I can put x outside this y integration. That case is to 1 to 2, and if I do this y integration, it will be ln y, and limit going from x to 2x, dx here, x equals to 1 to 2 x is ln 2x minus ln x if I put the limits dx. So now this term, it will be ln of 2x by x, right? And now we are not, so while we are integrating, at any point we are not taking x equals to 0, so we are going from x equals to 1 to 2. So in that case we can cancel this x, as x not is equal to 0 throughout this integration area, integration limit. So in that case this will be ln 2, and I can put, it's a constant, so I can put it outside the integration, and we are left with x dx where x equals to 1. So if I do the x integration, it will be 2 times x square by 2, and integration limit is going from 1 to 2. So if I put the limits, it will be 4 minus 1, and that is 3. It's 4 minus 1 by 2, that will be 3 by 2. So it will be 3 by 2 ln 2. Quantity is 3 by 2 ln 2, the first option. So this problem, the next problem is we have to find out the volume of the solid whose base is the region in the xy plane that is bounded by the parabola y equals to 4 minus x square and the line y equals to 3x, when the top of the solid is bounded by the plane z equals to x plus 4. Okay, so let me draw the xy plane, how the boundary looks like. This is x, y, so y equals to 3x, like this. So this is y equals to 3x, and the parabola will be y equals to 4 minus x square. So when x equals to 0, y is 4, and okay, when y is equals to 0, x will be plus 2 and minus 2, plus 2 minus 2 here. So these are the points parabola will pass through. So this point is 2 0, this point is minus 2 0. Okay. Extend it to cross this y equals to 3x line somewhere. So this is the y equals to 4 minus x square. Okay, fine. So let me find out these intersection points. For that, for these two intersection points, these two equations will simultaneously satisfy. So I can put y equals to 4 minus x square equals to 3x. So for these intersection points, 3x will be 4 minus x square. So it will be x square plus 3x minus 4 equals to 0, plus x. So it will be x plus 4 times x minus 1 equals to 0, plus we give two solutions, x equals to 1 and x equals to minus 4. For x equals to 1, y will be, for x equals to 1, y will be 3. Here if I put x equals to 1, and for x equals to minus 4, y will be minus 2. So these are the 2 points. So this is 1 3, and this point is minus 4 minus 2, and we need to integrate over this region. This is the area bounded by this y equals to 4 minus x square and y equals to 3x. Okay, and if I look at the plane, so there will be a z axis which will be just, you know, perpendicular to this plane, and the z coordinate will be x plus 4. So this is x equals to minus 4, and for any values which are any values of x, or which is greater than minus 4, the z will be above this plane, so the z will be positive. So basically throughout this integration, while we will be integrating throughout this area, z will always be either 0, so at this point it will be 0, and everywhere it will be positive. So we can find the small area element at any point x and y, which will be dx dy. So let me call it a dA. This is dA equals to dx dy. This is the area element, and the corresponding volume, if I multiply it with z, so it will give me the corresponding volume bounded by this region in the xy plane, and this z equals to 4 x plus 4 plane. Okay, so the dv will be z times d. So then the total volume will be double integral z times dA, which is double integral z times, so I need to write dy dx, but let's see what's the limit here. So okay, so I can do y integration first. So if I do the y integration first, so then it will give me, so along y axis I will go, so it will give me this area patch. Okay, so y integration, so y limit will be going from this line, this y equals to 3x to y equals to 4 minus x square. So if I do the y integration first, dy dx, so y will be going from, you can see for every x value y will be going from this line to this parabola. That means y will be going from 3x to 4 minus x square. So y will be going from 3x to 4 minus x square, and after we are done with this y integration, we need to move this region, move this area, small area patch throughout this x limit. So that's why we need to move x from minus 4 to 1. So x limit will be, so this is the minus 4 point and this is the extreme point on x, that is 1. So in that way we can cover the whole area. So x will be going from minus 4 to 1. Okay, so this will be the volume bounded by this area and this plane z equals to x plus 4. So x equals to minus 4 to 1, y equals to 3x to 4 minus x square, z equals to x plus 4 times dy dx. Okay, so okay, if anyone facing some problem of understanding how I am choosing these limits, how I am choosing these areas, please unmute and ask. So I am going slow here because I think choosing the area will be something tricky. Okay, so while doing, so this is only dependent on x, so you can put it outside while doing the y integration. So it will be x equals to minus 4 to 1, x minus 4, and if I do the y integration, it will be just integration of dy, that is y, and y limit is from 3x to 4 minus x square times dx. X equals to minus 4 to 1, x minus 4, and if I put the upper limit, it will be 4 minus x square, and lower limit is minus 3x dx, right? And then x minus 4 to x equals to minus 4 to 1. Yes, someone is asking something. X plus 4, this question. Okay, sorry, this is x plus 4. Yeah, x plus 4. Thanks. So z equals to x plus 4 here. Other limit side, right? Yeah. So now if I do the multiplication, it will be 4x minus x cube minus 3x square plus 16 minus 4x square minus 12x dx. Yeah, so right. And if I do a little simplification, x equals to minus 4. So x equals to minus 4 to 1. And if I do a little simplification, it will be minus, so it will be minus x cube minus 7x square is minus 7x square uh, minus 8x plus 16 dx. Now if I do the integration, it will be minus x to the power 4 by 4 minus 7 by 3 x cube minus 4x square plus 16x. Integration limit is going from x equals to minus 4 to 1. Please let me know if I'm doing some mistake at any point. So it will be, if I put the upper limit, it will be 1 by 4 minus 1 by 4 minus 7 by 3 minus 4 plus 16, and if I put the lower limit, it will be plus 4 to the power 4 by 4. 4 to the power 4 means 16 times 16 by 4, so it is 16 times 16 by 4, which will be 16 times 4, so it will be 16 times 4, right? So then it will be 64. Someone is saying 256. What is 256? Okay, let me do it first. This will be 64. Then the next term it will be minus 7 by 3 times 4 cube, and 4 cube is 64, so times 64. Then the next term it will be plus 4 times 4 square, that is again 64, and this term it will be plus 16 times 4, which will be again 64. So 64 times 3 plus 16 minus 4. Let me calculate it. 64 3, it will be 204. So if I calculate just these terms, 204 minus, so there is 7 by 3, here there is 7 by 3 minus 7 by 3, and here there is 64 minus 7 by 3, so there will be 65. 7 by 3 minus 1 by 4, and if I do this calculation, it will be, let me calculate, 65 minus into times 7 by 3, 5 times 7 by 3 minus 1 by 4 minus 1 by 4. So it will be 52.8333. Okay. So it will be 52.08333. So let me check the answers. Okay. Okay, if I'm going to write it in the fraction. So if I write it in the fraction, then convert it into fraction. Look at the options. 6, 5, 62 by 21. It's not 655. It's not 625 by 12. 625 by 12. Yes, so 625 by 12. So if I write it as a fraction, it will be 625 by 12. So the third option is the correct one. Someone is saying plus 7 by 3. This one, there is a minus sign. So this minus sign is correct, right? This minus sign, yes, this minus sign is correct because there is 4x square, there is 3x square. Yes. There is minus 7 by 3x cube. And if I put the upper limit, it will be minus 7 by 3. And if I put the lower limit, so there will be minus of this term. So minus of this term, so this minus will cancel. But there is a minus 4 cube, so minus term, another minus will come from there. So it will be minus 7 by 3 times 64, and there will be minus sign. So both term will have minus sign. Okay. Someone is saying 64. Which term is 64? No, it is 65. So there is 64 7 by 3 and there is 1 7 by 3 here also. So if I combine them both, then it will be 65. So you have 65 7 by 3. Okay, I think the rest of the calculations are correct. So this is 65 times 7 by 3. It is because of there is here 1 7 by 3, there is another 64 times 7 by 3. Okay. So if there is any confusion, please write in the comment section. I am moving towards the next problem. We don't have much time. So we have to find out the volume of this tetrahedron in the first octant bounded by the coordinate planes passing through 0, 1, 0, 0, okay, 0, 2, 0 and 0, 0, 3. We'll draw the plane x, y, z, and it is passing through 1, 0, 0, so it is passing through this point. The plane will be passing through 0, 2, 0, this point and this point. This is 1, this is 2, this length is 2 and this length is 3. Now if I write the equation of this plane, it will be x by this x intersection plus y by y intersection is 2 plus z by z intersection is 3 equals to 1. Okay, so this is the equation of this plane, and so we are asked to find out the volume of this plane or volume of this region bounded by this plane and this okay, and this first octant. So for that we will choose a small area element here. Okay, this is the dA equals to dx dy, and corresponding to that, if I multiply, so let me draw it. So I multiply it with z, so it will, so multiply it with z. Z is the height at this point. This is the plane. So multiply it with by z, so we will get the volume dV. Okay, so dV is z dA, and now we need to integrate over this plane in this xy plane, basically this small triangular region. Okay, so the volume will be then integration z dy dx double integral. So z is, I can find out from this, for any value of from this equation, z will be 3 times 1 minus x minus y by 2. Okay, so this is the z coordinate at any point xy, and our integration, so this, for integration we need to integrate in this plane, so in this xy plane. So in that case, we got this part. So in that case we can first integrate over y, right? So we can first integrate over y. So y will be going from then 0 to this line. So we need to find out the equation of this line. To find out the equation of this line, so this line is a part of this plane where z equals to 0. So in this plane equation, if I put z equals to 0, we will get the equation of this line. And in this plane equation, if I put z equals to 0, we will get y equals to 2 times 1 minus x. This is the equation of this line. So if I do y integration first along this plane, so it will be y limit will be going from 0 to this line, and then x will be going from 0 to 1. So then you can cover the whole triangular region. Okay, so y will be going from 0 to this line, 2 times 1 minus x, and x will be going from 0 to 1. x will be going from 0 to 1. Now x will be going from 0 to 1, will be going from 0 to 2 minus 2x, and z is 3 times 1 minus x minus y by 2, so I can put 3 here, 1 minus x minus y by 2 dy dx. So as y limit depends on x, we have to do y integration first. X equals to 0 to 1. By y integration, it will be y minus xy minus y by y square by 4, and y will be going from 0 to 2 times 1 minus x dx, 3 times x equals to 0 to 1. If I put the upper limit, it will be 2 minus 2x minus 2x plus 2x square, and this term, so it will be minus of 1 minus x whole square dx. So x equals to 0 to 1. If I do some simplification, it will be 2 minus, so 4x plus 2x square minus 1 minus x square plus 2x times dx. So it will be 3 times 0 to 1, so it will be 1 minus 2x plus x square dx. Now if I do this integration, it will be 3 x minus x square plus x cubed by 3, 0 to 1, it will be 3 times 1 minus 1 plus 1 by 3, so it will be 1 by 3 times, so this 1 cancels, it will be 1 by 3 times 3, and that is 1. So the correct answer will be 1. Okay, so the next problem, we have to integrate from 0 to pi. X will be going from 0 to pi, y will be going from x to pi, and we have to integrate sin x, sin y by y, dy dx. 0 to pi, x to pi, sin y by y, dy dx. Okay, sin y by y, doing this integration will be tricky, so we'll try a different way. Okay, so this is, let's draw the region where we are asked to integrate. So y will be going from, x is going from 0 to pi, this is 0, this is pi, let's say, and y is going from x to, so this is y equals to x, and let's say this is x, so, and this is y equals to pi. Okay, so x is going from 0 to pi and y will be going from x to pi, so this will be the region. This will be the region. this is y equals to x. Okay, so doing this integration sine y by y, it will be problematic. So for that, what we will do is we will shift the limits. So basically what we will do, so here what they are doing is, in this region, so they are doing the y integration first. That means they are going from y equals to x line, so from x to pi, so they are doing this integration first. They are doing this integration first, and then they are doing the integration over x from 0 to pi to cover the whole region. So if I move this small area element throughout this 0 to pi region along x, so it will cover the entire region. It will cover this entire area. Right? But instead of doing that, one can also do, one can also move along x first. So if one moves along x first, if one does the x integration first, so then x limit will be going from 0 to this line, and this line will be x equals to y, x equals to y. So x limit, if one does the x integration first, so x limit will be going from 0 to y, and then y limit will be going from 0 to pi, right? So then one can cover the same region. So in that case, this integration can also be written as sine y by y. I'm keeping it intact, and I'm doing the x integration first, so I'm writing dx before and then dy. X limit will be going from 0 to this line, that is x equals to y, so it will be x limit will be going from 0 to y, and then I will run this area element throughout this y limit, that will be 0 to pi. So y limit will be, so x limit will be 0 to y limit will be 0 to pi. So in that way I can also cover the whole region. Okay, now this integration is easy. Y equals to 0 to pi. So as I'm doing the x integration first, I can put the sine y by y outside. Sine y by y. If I do the x integration first, it will be y. Sorry, it will be x with limits from 0 to y dy. Equals to y equals to 0 to pi. So if I put the limit, it will be sine by y times y dy, right? So I can, so this y cancels, so y equals to 0 to pi sine y dy, and this integration will be minus cos y from 0 to pi, and if I put the limits, it will be minus of upper limit minus 1 minus lower limit 1, so it will be 2. Okay. So 2 is the correct answer. Okay. The next problem, we are asked to find out area enclosed by this leaf of the rose, one leaf of the rose. Okay, so let me draw it first. So r equals to 12 cos 3 theta. Okay, so when theta equals to 0 is x and y, so when theta equals to 0, here, that is, let me call it, this is a 12. Okay, this is 12, and so we are asked to find out the area of only one leaf. So one leaf means, now if I vary theta, so for theta equals to 0 it is 12, and now if I vary theta, it will at some point it will go to 0. So we can see that for cos pi by 2 is 0, so for theta equals to pi by 6, r will be 0, right? So if this is not exactly theta equals to pi by 6, but let me draw it like this for a better view. Okay, and again for theta equals to minus pi by 6 also, it will again go to 0. Theta equals to minus pi by 6, r will again go to 0. So it will look like basically this. At theta equals to pi by 6, it goes to 0, and then r increases as changing theta. It is going to, let me, so it will go to 12 as theta equals to 0, right? And now it will again come back as theta going to negative, and at minus pi by 6 it will again go to 0. This is one leaf, and we need to find out the area of this leaf. And now because of symmetry, you can see this cos theta is symmetric function along this 0. So if we find out area only along this part, we can multiply it by 2, or we can calculate the whole area. That's not a problem. Okay, so as we're in the r theta coordinate, I think the area or the leaf that they're talking about, that region is clear. If not, then please ask me in the comment section, or you can ask. So as we're in the cylindrical coordinate, the area element will be, sorry, we're in the plane polar coordinate, the area element will be, this is theta. So if I move along theta a little bit, this distance is r. So then this displacement is r d theta, and now if I move along r a little bit, it will be dr. So then we will cover the area element in the plane polar coordinate. So this area will be, dA will be dr times r d theta, or r dr d theta, right? So this is a small area element along at any point in this plane polar coordinate. So then the total area will be integration r dr d theta, while r will be going from, so for each, grab this, so for each value of theta, r will be going from 0 to this line, right? And this line is 12 cos 3 theta. So this is r equals to 12 cos 3 theta. Okay, so for each value of theta, r will be going from 0 to 12 cos 3 theta. So r will be going from 0 to 12 cos 3 theta. So this will be the r integration, and now theta will be going from 0 to pi by 6 for the 1/2 of this leaf, but if we want to calculate the entire leaf, it will be minus pi by 6 to pi by 6, right? Then it will cover the entire leaf. And now we can integrate. So minus pi by 6 to pi by 6, it will be r square by 2, putting the half outside, r square, the limit will be going from 0 to 12 cos 3 theta d theta. Then it will be half times 12 times 12 times cos square cos square 3 theta d theta. Theta will be going from minus pi by 6 to pi by 6. Now this 1 by 2 I can cancel 6, and I can write it 6 times 12, or I can write it 24 times 3, and this 3 I can put here, so 3 theta d of 3 theta, and it will be going from minus 5 by 6 to 5 by 6, right? So the 6 times 12 I'm writing it as 24 times 3, and 3 I'm putting it. So in that case, if I do the integration, okay, I can change the variable also. Let me write 3 theta equals to 5, then the limit will be going from, so as theta is pi by 6, phi will be pi by 2, and as theta is minus pi by 6, phi will be minus pi by 2, right? So then this integration will be 24 times minus pi by 2, 2 pi by 2 cos square phi d phi. Okay, this 24 I can write it as 12 times 2, so 2 cos square phi I can write as 1 plus cos 2 phi. Now if I do the integration, it will be 12 times phi plus sine 2 phi by 2. Integration limit is going from minus pi by 2 to pi by 2. Okay, and now if I put this limit, so it is 12 times pi by 2 plus, so sine pi 2 times phi, 2 times pi by 2 is sine pi 0, and for the lower limit will be plus pi by 2 again, and the subterm will again be 0. So we are left with 12 pi. This is the area of this leaf, 12 pi. Next problem. Choose the correct form of Cartesian integral in the following polar integral. So the polar integral is 0 to pi by 4. There is a theta limit, and r limit is 0 to 2 sec theta, so r to the power 5 sine square theta dr d theta. Okay, so just for the conversion from polar to Cartesian, this is theta, this is r, then corresponding, if this is the x and this is the y, then x is r cos theta, y is r sin theta. So this, and we also saw that r dr d theta is basically dx dy. It's the area element in this polar coordinate, and dx dy is the area element in the Cartesian coordinate. So then this r to the power 5 sin theta dr d theta, this quantity, this we can write as r square times r square sin square theta times r dr d theta. Okay, this is the area element. So this r square I can write as r square sin square theta plus r square cos square theta times r square sine square theta, and this is area element dA. And now I can replace it by this x and y values. So it will be, so this r square cos square theta will be x square, r square sine square theta will be y square, and this will again be y square. So we have x square plus y square times y square times dA in the Cartesian coordinate is dx dy. And now we need to think about these limits. Okay, so r is going from, okay, the limits are, let me write the limits. This r is going from 0 to 2 sec theta, 2 sec theta, and theta is going from 0 to pi by 4, right? Yeah, theta is going from 0 to pi by 4. Okay, so in that case, how the region where we are integrating, that will look like, this is x, this is y, and r is going from 0 to 2 sec theta. So for theta equals to 0, r will go from 0 to, so for theta equals to 0, sec theta equals to 0, sec theta is 1, so r will go from, r will move along this line, so it will go from 0 to 2, right? So r will go from 0 to 2, and for sec, so for theta equals to pi by 4, so when theta equals to pi by 4, so this is the highest limit of theta, when theta equals to pi by 4, r will go, so this sec theta is root 2, so r will go from 2 root, r will be 2, 0 to 2 root 2, this is the 2 root 2, right? So basically we will be moving along this region, as r is going from 0 to 2 sec theta, and theta will be going from 0 to pi by 4. Okay, and so this length is 2, and as this is 2 root 2, so this length will be again 2, right? And this line will be y equals to x. This is the 45-degree angle. So our integration region will be, if I do the x integration, if I do the y integration first, so then it will be x and y. So if we do the y integration first to cover this region, it will be, y will be going from 0 to x, so y will be going from 0 to x, and x will be going from 0 to 2, so x will be going from 0 to 2. Okay, if I do the y integration first, so then it will be y square times x square plus y square dy dx. And if I do the x integration first, then x y, if I do the x integration first, so then x will be going from this line to this line, so x will be going from, this is the x equals to y, and this is x equals to 2, right? So x will be going from y to 2, and y will be going from, I am writing this term also, plus y square, I am doing x first, and then dy, and y will be going from 0 to 2. So y will be going from 0 to 2. Okay, these two integrations are equivalent. These two integrations in Cartesian coordinate, it is equivalent to this integration in this polar coordinate. So the correct option will be x is going from 0 to 2, y is going from 0 to x is going from the first one, x is going from 0 to 2 and y is going from 0 to x. This is the correct option. And for this one, y will be going from, x will be going from y to 2 and y will be going from 0 to 2. So if you do the x integration first, so in these two equations they are doing x integration first, x will be going from y to 2 and y will be going from, so this is also correct. Please even explain. Okay. Okay, let me explain it again. So this is an integration in the polar coordinate, right? So we have to convert this integration in the Cartesian coordinate. So now I have just written the transformations like x equals to r cos theta, y equals to r sin theta. I think this is pretty clear. So this, I am replacing this part, whatever we are going to integrate, so by this xy coordinate. So for example, this whole thing, this r to the power 5 sine square dr d theta, this term, so I am writing it as r square times r square sine square theta. Why I am writing it as r square sine square theta? Because I need to replace this sine theta part through this y, so and this y has a r multiplied with it, so I need r sine theta here. And the area element in this plane polar coordinate is r dr d theta, so this is the dA, and I am writing r square as r square sine square theta plus r square cos square theta, so it is giving me x square plus y square. So and this is y square, and this dA in Cartesian coordinate, area element in Cartesian coordinate is dx dy. So this is the entire thing. So this r square sine square theta dr d theta, this can be replaced by this quantity. And now we will think about this limit. So this limit, so this is the r limit. So r is here, the r was going from 0 to 2 sec theta, and theta was going from 0 to pi by 4. So this is what I wrote here. R is going from 0 to 2 sec theta, and theta was going from 0 to pi by 4. Okay. So, and for example, if I write this x coordinate, simple x equals to, we know that r cos theta, right? So what does this mean? It means that the upper limit of r, it is going up to 2 sec theta, right? And now if I put this value, so then we can see x is going from, so for r equals to 0 we are here, so x, this is the lower limit of x, and x is going from at a maximum. So if I put the upper limit of r, that is 2 sec theta, it will give 2. So x is, for each value of this r, as we are moving along this r, for each value of theta, r is covering these kind of distances for each value of theta, but x is always going from 0 to 2. Okay, for all theta, x is going from 0 to 2. So we are limited, the x integration limit or x integration region is limited from 0 to 2. And at point okay, at point, so and theta we are moving from 0 to 45 degree, pi by 4. So and so at 45 degree r, so the value of r will be, so this is 0 to 2 root 2, because if I root theta equals to 45 degree, it will be root 2, sec theta will be root 2 and 2 times root 2. This length is 2 root 2. Okay. So basically our region will be then this triangle. So throughout this triangle we need to integrate, and if we want to integrate throughout this triangle, this is the same triangle, this line will be y equals to x because this angle is 45 degree, right? So in that case, so there are two ways I can integrate. One is I can integrate y first and then x. So here in the first term, that's what I am doing. So I am putting everything as it is from here. This term I put here, and now I am talking about these limits. So how to modify these limits to cover this entire area. So to cover this area, y should be going from 0 to this line, and this line is y equals to x. So y, for each value of x, y should be going from 0 to x. So in that way we are covering this small area element, and now we will move this area element from x equals to, as we move, so this area element will vary with x basically, and as we move this area element from x equals to 0 to 2, we will cover this entire area. This is how I wrote this limit. So up to this point, is it clear? And the another way is I can integrate x first. So if I do x integration first, so x will be going from this point to this point. This is the x axis. So for any value of y, x will be going from this x equals to y line to this point 2, right? So x, upper limit of x is fixed. It is always going to 2. So x will be going from this line, that means x equals to y to 2. Okay, so this is the x limit, and now for that, for any value of y, when x is going from y to 2, we are covering this small area patch. And now if I move this area element throughout this region, that means from y equals to 0 to 2, we will cover the entire area. So that's the another way of integrating, where we are integrating the x first. Okay, so these two are the possible forms if I replace it with in the Cartesian coordinate. If not clear, then please unmute and ask at some specific point where it is not clear. Or write in the comment section also. Okay, so the last one is, so this is a very easy problem. Last one is a 1 to e, so z integration, it is for z integration this term, for y integration this term, and for x integration this limit. This is for z equals to 1 to e, and then this y equals to 1 to e square, and then this x equals to 1 to e cube, 1 by x y z dx dy dz. And now these limits doesn't depend on each other, so I can do this integration separately. So basically I can do z equals to 1 to e 1 by z dz separately. I can do y equals to 1 to e square 1 by y dy, because here also I can separate 1 by x, 1 by y, 1 by z separately. So, and the last term will be x equals to 1 to e cube 1 by x dx. Now if I do the integration, it will be ln z from 1 to e multiplied with ln y from 1 to e square multiplied with ln x from 1 to e cube. Now if I put the limits, it will be ln e minus ln 1. ln 1 is 0, so let me write it ln e, and ln e is 1, so let me write it as 1 times is ln e square minus ln 1. ln 1 is 0, so ln e square is 2 times, then again ln e cube is 3, ln e cube is 3, and if I put the lower limit, that will again be 0, so it will be 6. So the correct answer is 6. So these were the 10 problems. Today's class is a little bit lengthy, so if any of these problems you couldn't understood at any point, please ask me in the comment section or unmute and ask, or you have any confusions in regarding the lecture videos. So, yeah, thanks Dhanaraj for joining this session. Okay, so if there is no more questions, then stop sharing. So I'm ending this class. Then, yeah, thanks for joining.